Hello, space enthusiasts! Today we continue our journey into the fascinating world of astronomy with the Renaissance period. In our past videos, we have explored astronomy from prehistoric times through Mesopotamia, ancient Greece, India, China, Islamic cultures, and the European Middle Ages. Now we continue our journey through history with the Renaissance. European astronomy reached the level of the ancient Greeks only after the publication of the Epitome of Ptolemy's Almagest, begun and completed by Georg von Peuerbach and his student Regiomontanus in 1496 during the Renaissance. This work contributed greatly to the learning of Ptolemy by new generations. During the Renaissance, astronomy underwent a major transformation known as the Copernican Revolution. This revolution is named after the Polish astronomer Nikolas Copernicus. In his work, De Revolutionibus Orbium Coelestium Libri VI, 6 books on the revolutions of the celestial spheres, written in 1543, Copernicus presented the motion of the Earth and the heliocentric system. His claim that the planets revolved around the Sun, not the Earth, caused great controversy for a long time. Copernicus discovered the motion of the planets by blending the information in Ptolemy's Almagest. The inner planets are always close to the Sun. Mercury is never more than 22 degrees from the Sun, and Venus never more than 48 degrees. This simply explains that the inner planets revolve around the Sun. The Danish astronomer Tycho Brahe is a good example of those who admire Copernicus's success in linking all the motions of the planets more closely to the Sun, but cannot accept the motion of the Earth. Tycho blended the mathematical contributions of the Copernican system and the concrete physical contributions of the Ptolemaic system to create the Tychonic system. This was the system believed in by those who did not accept Copernicus's heliocentric system, but could no longer accept Ptolemy's system. In this understanding, the Moon and the Sun revolved around the Earth, but all other planets revolved around the Sun. In fact, this structure was similar to what the Copernican system would look like if the Earth were fixed. Tycho was also known for his observations. Like many other astronomers, Tycho was impressed by a new bright star. We now know it was a supernova that appeared in the constellation of the Queen, Cassiopeia, in 1572. He made extensive nightly observations to see if this celestial object changed its position relative to other neighboring stars. From an Aristotelian point of view, it was difficult for an astronomer or philosopher to accept the idea of a new star appearing in the heavens. They were more likely to think of it as a phenomenon occurring in the upper reaches of the elements of air and fire, which in Aristotelian cosmology were thought to cover the land and seas. If a new star exhibited parallax motion, moving back and forth relative to known real stars, they would be sure that it was something close to Earth, and not an object belonging to the cosmic sphere. Tycho's demonstration that this new star did not have any measurable parallax, and that it was indeed a star belonging to the celestial sphere, was a major breakthrough in overturning the old physics. In 1577, there was a second gift from the heavens, a very bright comet. In antiquity and the Middle Ages, comets were seen as atmospheric phenomena. Aristotle, too, did not include them in his book, On the Sky, but in his work Meteorology. After all, they were ephemeral, transient objects that appeared suddenly, moved rapidly from one constellation to another, and disappeared from sight. But Tycho was able to model the motion of this comet in orbit around the Sun. Tycho pointed out that the comet was sometimes closer to Earth than Mercury and Venus, and sometimes farther away. This notation implied that the comet hit the celestial spheres that carried the planets. Thus began the process of questioning these vast structures. In 1609, Italian scientist Galileo Galilei built his own telescope, inspired by the telescope recently invented by Dutchman Hans Lippershey, and pointed it at the sky. Galileo was able to observe many details that had previously been invisible to the naked eye. When he observed the Moon, he discovered that the Moon's surface was not as smooth as it looked from Earth, but was covered with mountains and craters. Galileo was also able to measure the height of these mountains by using the shadows of the mountains on the Moon's surface. When he looked at a nebula, he discovered that this nebula actually contained many small stars, and that even the Milky Way was made up of stars. But perhaps his most remarkable discovery was the discovery of 4 moons orbiting Jupiter. When Galileo first observed Jupiter, he saw 3 small spheres around Jupiter. But the next night, Galileo turned his telescope back to Jupiter and discovered that there were actually 4 spheres. Galileo observed Jupiter for weeks and realized that these spheres revolved around Jupiter. He later named these stars Medici stars, after the Medici family who financed him. Galileo published these discoveries in his book Sidereus Nuncius, which also made him famous. Although Galileo's discoveries could not directly prove Copernicus's theory, they supported it. For example, the fact that Jupiter has moons orbiting it is not proof that the Earth revolves around the Sun, but it is proof that there is a center of rotation other than the Earth. Galileo's discoveries also showed that a moving planet can carry satellites with it, just as the Moon and Earth move in Copernicus's theory. Galileo later observed that Venus, like the Moon, goes through different phases. Although this observation refuted Ptolemy's theory, it did not refute Tycho Brahe's theory that the planets revolve around the Sun and the Sun revolves around the Earth. Another discovery of Galileo was the rings of Saturn. In 1610, looking at Saturn with his telescope, Galileo noticed that there were 2 small spheres around Saturn, but later, when he observed the planet again, he realized that these spheres had disappeared. This is because the rings are perpendicular to the Earth. However, Galileo could not understand exactly why this was the case. In addition to all this, Galileo also observed that there were spots on the Sun. In 1615, Galileo's writings on heliocentrism attracted the attention of the Inquisition, and Galileo traveled to Rome to defend his ideas. In 1616, the Catholic Church declared heliocentrism foolish and philosophically absurd because it did not agree with Scripture. In the same year, Pope Paul V ordered this to be communicated to Galileo and ordered him to abandon his belief in heliocentrism, and also banned Copernicus's book on the revolutions of the celestial spheres. For a long time, Galileo was afraid of running afoul of the Church, but in 1623, encouraged by the accession of Pope Urban VII, a friend of his, Galileo published his dialogue concerning the 2 chief world systems in 1632 with papal approval. The German astronomer Johannes Kepler studied at the University of Tübingen in 1589, where he learned about both Copernicus's and Ptolemy's models of the solar system. After this period, he began to believe that Copernicus's ideas were correct. One of the biggest turning points in Copernicus's life was the invitation from the Danish astronomer Tycho Brahe to work together in 1600. Tycho Brahe was working for the Holy Roman Emperor Rudolf II in Prague at the time. Kepler, thinking that he could use Tycho's planetary parameters to develop his own cosmological system, accepted the invitation and went to Prague to work with Tycho. However, this partnership was short-lived as Tycho died in 1601. When Kepler arrived in Prague, Tycho and his assistants were observing the planet Mars, which was passing close to Earth at the time. This was a great chance for Kepler because only the orbits of Mars and Mercury are elliptical enough to leave the circle, and Mercury is very difficult to observe because it is so close to the Sun. After Tycho's death, Kepler had access to Tycho's observation records, which Kepler analyzed because they had not been analyzed for use in astronomy. Since Kepler was a Copernican, he put the Sun at the center of his model of the solar system, but for technical details such as the motion of the planets, he used Ptolemy's law of equant. Kepler tried to explain the elliptical orbit of the planet Mars with equants, but the orbit resulting from the use of the equant point did not coincide with Tycho's observations. Thereupon, Kepler had to re-examine the motions of the planets. As a result of his studies, he came up with the first 2 Kepler's laws and published these ideas in his book Astronomia Nova in 1609. Kepler published his 3rd law in 1619 in his book The Harmony of the World, Harmonics Mundi. Kepler's first law, each planet moves in an elliptical orbit with the Sun at one of its foci. Kepler's second law, the vector of a planet's radius from the Sun sweeps equal intervals at equal intervals of time. Kepler's third law, the square of a planet's period around the Sun is proportional to its distance from the Sun. Thank you for joining us today. The discoveries and historical developments we've learned about on this journey into the fascinating world of astronomy have shown us once again how important and exciting science is. If you want to see more science and space-related content, don't forget to subscribe to our channel and turn on notifications. If you liked our video, please share it and let us know what you think in the comments. See you in the next video. Bye!